Hello, everyone, and thank you for joining us at our blockchain session. Before we start, I would like to create an introduction. SNIA recently formed a group called Technical Workgroup for Blockchain, and you can join us at memberships at snia.org. We are looking for your insights. We're looking for your expertise to create an interoperability specification for open source SNIA IP, which can be utilized by the community and can join all disjointed blockchains into one common community, and there will be an interoperability interface for it. On that note, allow me to start. My name is Olga, and my counterpart is Andrew, and we'll be talking today about the blockchain and storage applications. When we're talking about blockchain, there is a lot of different concepts and conceptualizations. But what I'd like to talk about is the concept of the basic architecture of a blockchain, and also the focus on blockchain and storage, and what's the current state of a blockchain in storage. So what is a blockchain? Blockchain consists of the block of data and also hash. The block of data, it's a blockchain itself is a distributed database of records, which is built out of data blocks. And hash is a cryptography which allows you to validate each block. You have a current hash and a previous hash. And then we also have different factors which can affect users. But the most importantly, each block of data with the hash, when you connect it together, builds a so-called chain. So now let's break it down to this is my attempt to definitions. I'm not saying it's right, I'm not saying it's wrong, but this is how I would view the blockchain today. So what is blockchain today? It's a data construct or blockchain construct based on a Merkle tree data structure. And it allows you to build a chain using hashes and data blocks. And so blockchain itself can use a different cryptographic hash algorithms, such as SHA-256 is one of the most popular. That doesn't mean that we have SHA-1, SHA-2, SHA-3. There is a number of cryptographic functions. The small deviation cryptography existed back in Byzantine times, and people had encoders and decoders, so this is not new. What's new is the application itself, and Satoshi Hashimoto, who published a paper in 2018 on a Bitcoin, created what I could call a new era in technology when it comes to implementations. And the first applications, of course, were built for cryptocurrencies, but that's not limited to cryptocurrencies. In fact, it's most effectively used in building business applications such as supply chain, inventory management, anything where you require authentication of the original product or original data would be perfect for the blockchain. And so we covered hashes, right? And then another concept which is commonly used is called consensus protocols. It's a consensus protocol is used for decision-making process to make the record valid in a distributed ledger. Today, the consensus protocols which are commonly used is proof of work, proof of stake, proof of space, which we will be talking about, and many others. I'm sure this audience, one way or another, interacted with that. Consensus protocols using, as I mentioned, distributed ledger, and they make the record of the block, and then the data gets transferred to the next. So let's segue into our discussion of the blockchain and storage, because that's close to what we do, that's close to our heart, near and dear. And in blockchain and storage, we have two so-called consensus protocols which are used interchangeably. There is more right now which I observed and getting developed, so we probably will see a slew of other consensus protocols, but let's say today we have proof of capacity is one of the most popular, and it uses a SHA-256 cryptographic function to validate the capacity of the storage device used in mining. One of the benefits of SHA-256, it fits the I/O requirements because basically you are doing I/O memory writes, and it's ASIC resistant. Another benefit is when you are using this SHA-256 or proof of capacity consensus protocol itself, so it's not SHA-256, but it's a consensus protocol proof of capacity. First thing first, what you do is you plot the drive, or you format the drive, in other words, and that formatting happens in the form of back-to-back memory writes. It's where you are processing, assigning hash and data block size. Each one is equal. And once you finished that, the next step which you will be doing, you'll start doing so-called mining, and where you are reading a plot by doing a memory reads and submitting answers plus a deadline, time to read for actual nonce. The power requirements when you are using such proof of capacity, since we're doing it on a storage devices like SSDs, HDDs, or NVMe's, is very low. So in terms of power consumption, it's one of the most energy efficient consensus protocols. And the way you move data on a chain, you have, like I mentioned in the first slide, we have a data block and the hash with the previous hash and the current hash, and you start moving it. So it's a current hash with the previous cache, and they move the block. And this is your normal round, and that's the final round where you're utilizing it and finalizing the data. The proof of space, like I said, is interchangeably used with the proof of capacity. And it means that showing one legitimate and interest in a service. Proof of space is, or proof of capacity is similar to proof of work. But in this case, like we just mentioned before, storage is used. You are also using hard to memory functions and proof of retrievability. This is an alternative to Bitcoin and proof of work algorithm as a mining, and one of the way to mine cryptocurrency. Proof of space is more energy efficient. For example, if you are using 1000 kilowatts versus 0.24 kilowatts, that's how Burstcoin versus Bitcoin. So Bitcoin is using 1000 kilowatts since you're using computational CPU power versus the storage memory read writes. And in this case, let me remind you that you plot the drive only once and then you start doing memory reads. In fact, it's very excellent. One of the great applications which I find useful is you can do benchmarking on your memory writes if you're using it for the NVMe device. So you are just creating a so-called plot diagram, and it will tell you how your storage space is utilized, and when you format it with the equal height and width, and you apply the cryptographic function. Let's talk about blockchain and proof of capacity. So how does the plotting works? Plotting is a process of generating plot files, which are just files storing large number of pre-computed hashes, and each plot file contains one or more group of 1092 hashes. 8,192 hashes, and they are called so-called nonsense. So this is your nonce number, that's your byte account ID, and this is your hash, right? So we have 8,192, 32 bytes per hash, and each nonce is for 256 KB. Like I said, you have actual equal height and width for each so-called nonce. What happens is you map it, you divide it in a 4096 pair of hashes, and then this pair of hashes called scoops. And then you can add the indexing. So basically what it does, it makes sure that each block is formatted, indexed, and there is no overlapping of data or data compensation, because each block is already assigned a certain slot in a memory of the storage device. When you format it with so-called nonsense, and you are already have this formatted drive, we divide nonsense and we create a so-called mirroring. What it does, the mirroring prevents us from creating a fake data blocks. It also allows you to maintain the integrity of the data and maintain the accuracy of the data. And what that happens is, if you look at it, so this is your nonce and the mirror of that nonce in a 4094. And then you have a nonce scoop 1, and then that scoop 1 will be in your nonce sorry, the scoop 0 will be nonce 4094, scoop 1 will be 4095, and etc. So you basically, even if you shuffle data, you still will have a correct second hash on every data. So, and now let's talk about Burstcoin. So Burstcoin itself was the first cryptocurrency to use the proof of capacity algorithm. And Burstcoin was first cryptocurrency implemented to read complete in a smart contracts in a live environment in the form of automated transactions. Burstcoin is used in decentralized crowdsourcing and crowdfunding. The founders of the Burstcoin developed it as an open source code, and community keeps maintaining it, so it's completely open to everyone, and everyone can become an evangelist or just the developer in the community and use code to add more features to the Burstcoin itself. Currently, Burstcoin is quite popular. It's listed on several crypto exchanges, and one of the benefits, it's used for different type of transactions, like in real estate payments. I've seen it in logistics applications, some banking financial transactions. Um, and how would you use it? Anyone who wants to learn more, the barrier to entry is very low. You basically need a hard drive and plot it, like I mentioned, by doing memory writes, and then create a miner. And once you have that miner, you are adding yourself to the pool of other miners and start contributing your resources to the community, and at the same time get the benefit of the miners awards. When you are mining, you can do it in two different ways. You can do it as a solo mine or as a pool miner. As a solo miner, you submit it to network directly, basically your node, and without going to a pool. Then you also have a pool miner and you can select the pool which you want to run and then start mining as a pool. Some pools are using proceeds, and Burstcoin community is quite popular actually. They are using proceeds of the mining to doing some social good initiative for environmentally friendly initiatives or support after the natural disasters. It's actually quite popular in the community, and its community is very generous when it comes to support of the people in need. Last year, with the compliments of Western Digital and Supermicro, I was able to build two miners. And as you can see over here, you have an NVMe Open Fabrics miner from Western Digital with HP platform, and next to it is a plotting. So that plotting is what with step 1, where you format with hard drive. The NVMe drive was 7.2 terabytes. And once you split it into equal blocks, nonsense, like I mentioned, create the full map of it with each indexing. You have the blue is the memory writes, and the greens are, I'm sorry, the blue is nonsense and green are memory writes back to back. As you can see, each block is mapped. And it took me 5 hours, 11 minutes to map and plot back to back 7 terabytes of memory. If I would do it on a standard SATA drive with 6 gig SATA drive, 6 gigabits per second SATA drive, it would take me about 22 days to map the same way. Because don't forget that I'm not only plotting it and doing memory back-to-back writes, I'm also applying hashing and I'm doing a data mirroring. So in fact, this is a great tool to do the benchmarking to a certain extent. Let's talk about decentralized concept and how can it be effectively used in NVMe. When it comes to the decentralization concepts, we are talking about architectural decentralization, political decentralization, and logical decentralization. When we talk about decentralization and NVMe, we're talking about fault tolerance as an advantages, attack resistance, collusion resistance. As a disadvantages, it's lack of focus for too many decision makers, yes. Speed of action, NVMe devices are becoming very fast, so maybe we will soon consider it as advantage. And duplication of work, the data mirroring does create a duplication, and we all recognize that. And this brings us to the point which I would like to speak with everyone. So blockchain today is ramping up and becoming not only a concept, but finding itself in a business cases and business use. And the companies have business applications which we are building and adopting. IBM Hyperledger, Ripple applications. They are highly good examples of what's happening in the community. So if we build an but there is one big disadvantage. Ripple doesn't talk to Ethereum. Ethereum doesn't talk to IBM Hyperledger. So what we need to do as a community, we need to start thinking about what can we build in existing storage architecture or for forward-thinking storage architecture by utilizing latest trends in NVM and NVMe, where we will create this interoperability between chains. One of the things which comes to mind is we need to create an open source IP, like I mentioned, and that IP will allow us to create the bridges between different blockchains today and in the future. On that note, allow me to pass the floor to my colleague and friend, Andrew, and let's talk about blockchain in the future.
Now, when we discuss the current state of the blockchain and basic principles behind the technology, it is a good time to ask a question. What do we need to take the full advantage of the technology? And the simplest answer is that at the current stage of the development, what we really need is a common specification. Why do we need such specification? Because after years of experiments, we have an understanding of common pain points we need to address in order for the blockchain to become enterprise-grade technology. Really, for market adoption and a common specification is a good start. What are the needs we need to fulfill? First need is scalability. Unfortunately, in terms of users and transaction volumes, existing blockchains cannot compete with their traditional centralized counterparts. Second need is the cost of transaction. And we have two components here: the cost of consensus and the cost of thinking the chain across the whole network. Both could be the issues when we talk about the real-world performance, especially in the case of IoT transactions. Third need is interoperability. The blockchain is a network, and like any other network, its value depends on the amount of participants. To be able to connect as many participants as possible, they all have to speak the same language. The last one need is a special case. A case that is the ideal application of the blockchain. A case of transferring the right or value from one entity to the other. To handle this case properly, the blockchain needs to be flexible enough to accommodate multiple legal and business requirements. These are the questions we need to answer. And what I would like to do next is to discuss some approaches that can help answering them. The first key concept we need to rethink is the concept of a single chain. And the reason is not only because having a single chain creates an unsolvable scalability and performance issue that grow with each transaction and the size of the chain. We also have less technological, but even more important business reason for it. First reason is that, in reality, for any transaction, the only person who do really care about it are participants. The rest of the world doesn't care. And while automatically distributing the copy of each transaction to everyone in a network looks like an interesting and fancy idea, it is just a spam and waste of the network resources. The second reason is privacy. We want blockchain to be used by multiple different companies in different countries. And for sure, these companies and countries would have privacy concerns and would not be willing to put all their data into a single chain that's available for everyone else to see, probably including their own competitors or even worse, their own enemies to observe. Third reason is that 90% of the data in a blockchain will be obsolete and outdated really soon. Having a single chain with all this outdated data is like being a dinosaur with a long, heavy tail. Slow and slow.
Andrew, thank you very much for a great presentation
Finally,
and providing such
with a single
valuable
chain,
insights. So
we
now
have
I
a
would
thin
like to wrap
restriction
up,
on the size of the chain
to the closing
and on the amount of
of
data we
our
can put
presentation.
on it,
Andrew,
which
thank you
make the
very much
chain and the
for
whole blockchain much less
providing great
useful and
insights and
applicable
what
for the real business
we
cases.
would like to propose. So with this,
What
I
is the
would like
solution?
to present you
The blockchain with
the
multiple chains.
proposed blockchain interoperability
When we have
architecture
multiple chains,
from
we
our
can
technical
focus
work
only
group at
on active
SNIA,
chains with actual
where we
data,
will build
and we don't have to worry
the
about the
blockchain
rest.
layer with the storage, and then we'll have
With multiple chains,
distributed ledger,
we can easily
blockchain
implement
services, smart
sharding
nodes,
and get the
authentications,
boost in
and API.
scalability and
This is
performance.
all still in the early stages,
With multiple
so
chains, we can
stay
also
tuned.
easily implement the concept of private and public
And
chain
I
with
would like
different levels of
to ask
visibility
everyone in this
and address the
audience
privacy
to
concerns.
get involved. If you're part of SNIA member,
And
please join our technical
because we
group.
don't have such
If
an
you're
extreme
not part of
restrictions
SNIA, please
on
join
the
us
size of the
as a
chain,
member of SNIA and join
we
our
can put much
technical
more
group.
data in each
You can
chain and make
contact
it
us at
much more useful.
membership@snia.org or Olga at my ActionSpot.
At the same time,
And it will allow us to create
we
a
want to make
community
sure that each
where
chain
we will
and
build
data
an
in it
effective and viable
are as
solution
secured
for
and
blockchain
protected as in
interoperability.
the case of a single one.
Any questions?
We can use different methods to achieve this goal. I would like to
Thank you
show
very
just
much
one
for
example.
attending today's sessions, and I'm looking forward to your feedback.
Here, We are using an additional unique pair of private and public keys to add a new block. It works that way. Each time we create a new block, we also create a new pair of keys and store the public key in this block. The private key we created will be used on the next step to sign the next block in the chain, and it will be deleted immediately after that. That way, we create additional link between the blocks and can use public key from the previous block to verify the current one. So for a person, even for the creator of the chain, to modify it would require to have all the private keys that were used for its creation. And we can make it even almost less impossible to do if we will put process of generation of the pair to a special secure container, and if we wouldn't handle the private keys to the users at all, because we don't have to. A reasonable question to ask is what happens if for some reason we would lose the private key before we can create the next block. With an architecture like this, nothing extreme would happen. We will close the chain, and we will start a new one with a new key. So, here we have a little redundancy, and as a result, a double bulletproof solution. Forward and talk about the second important topic, consensus in a blockchain. First, we have to admit that even simplest version of distributed consensus is still too expensive if we want to support high volume, low value transactions, the kind of transactions IoT requires. Second, by definition, consensus is designed to support a specific business case. And if you have a blockchain with pre-built consensus, we actually have a single case blockchain. Definitely we can use this kind of blockchain for different purposes, but if we do, pre-built consensus wouldn't bring any real value and will only consume the resources. The one interesting corollary is that if you will use blockchain for multiple different use cases, we also would need to design multiple consensuses that can handle them. Third, the purpose of consensus is to prevent potential harm by validating the transaction. So here we have two variables, the cost of the potential harm and the cost of its prevention. We definitely want to use consensus only and only if the cost of the harm is bigger than the cost of its validation, which is not always the case. When we talk about the value of consensus, we also need to keep in mind the simple fact that some data are put on blockchain doesn't make them automatically correct or true. Blockchain cannot verify the data or vet on them. The only thing it can do is to keep them unchanged and make that way the creator more accountable for the data. So, as a result, we can trust the data on a blockchain as much as we can trust the entity that created them. We also need to remember that in real-world transactions, most of the action would happen outside of the chain, which also limits the ability of the consensus to add real value. And it requires to know the real identity of participants, because if something goes wrong outside of the chain, we need the identity to work on fixing the situation. So what we really need here, we need a blockchain that can work without the consensus on a basic level, and at the same time can support multiple different versions of consensus when it is required by the nature of the different transactions. In our architecture with multiple chains, to avoid consensus, we can make each chain a single entity statements chain, or a chain that represents a record created only by one entity and signed with the personal private key of this entity, a personal book. As a result, we don't have to validate any new records in this chain. What if two or more entities want to transact to each other? All they need to do is just to share the relevant personal chains with each other and to use the information from these chains to move forward. Let's look at the example. We have two entities here with personal chains. Entity 1 is sharing green personal chain with entity 2, and entity 2 is sharing blue personal chain with entity 1. Each new update in a shared chain is immediately propagated to all its copies. We also have an observer who sees both blue and green chains. For example, it could be a regulator. That way, we can handle a very complex transactions with multiple participants and with minimum resources. Now, let's talk about security of private keys. Private keys are at the core of modern cryptography and at the foundation of the blockchain as a technology. In blockchain, they represent the identity of participant, they protect the data and the chain itself. And they can do it as long as they are not compromised. So private keys themselves do need protection. The challenge is that, like with other passwords, private keys have to be kept and used by people. And we know that we cannot count on people's abilities at keeping multiple passwords in their mind. Like with other passwords, eventually private keys will be lost or compromised, especially if they are used often. And there are many of them. Existing blockchains designed to punish users who expose their keys, and especially users who lose them. A common excuse here is that it is necessary to keep anonymity of the users, and this excuse advertised as an advantage of the blockchain. But the reality is quite an opposite. Anonymity doesn't help for real-world transactions that involve out-of-chain actions. It doesn't make any data in blockchain more reliable, and it only increases the risk that if something goes wrong, a victim wouldn't be able to take any actions against the opposite side. For the mass adoption of the blockchain, we need to stop focusing on anonymity of its user, accept the fact that the people do make mistakes, and start focusing on preventing the potential harm from compromised and lost keys. And here we can take the same approach as with compromised credit cards. Block the old ones, close the chains that were created with the compromised keys, and reissue new keys to the users after they confirm their identity. We can even make a policy to automatically reissue keys on a regular basis like with credit cards. Don't forget, real-world interactions and the way society operates are based on our identity. And you probably don't need and don't have to reinvent the wheels here. Even more about topic of privacy, but from the other side. We don't have yet adoption of the blockchain at a scale, but we already have the competition and compatible solution from different vendors. Blockchain is not designed to be used in-house. It is an outside network, and like any other network, its value depends on the amount of participants that can use it. And if we would have multiple incompatible blockchain networks, we would probably have a situation like we have right now in the messenger space, when a person have to use 10 plus messengers and none of them can talk to each other. Probably it is the lack of interoperability that is one of the key reasons why businesses still use email as the main official communication channel. Taking into account that the goal of the blockchain is to help handling business transactions between multiple different participants, we do need interoperability as one of the crucial requirements for its adoption. From the history of truly interoperable protocols, like GSM, email, or even Internet, we know that the key condition is for the protocol to be public, free, and open source. So, with blockchain we have no chance but to open source some key elements if you want to really create a new interoperable solution, not a closed loop ecosystem. We need to open source some basic building blocks, the protocol or the common language, the network architecture, and the ledger structure. Keep in mind that like with other protocols, it doesn't prevent vendors from creating proprietary solutions with unique features. But it makes them compatible on a basic level and reduces the risk of vendor lock-in for their clients. So it's a win-win situation. What we discussed till now was a stateless blockchain. A blockchain that doesn't incorporate any particular business logic to support any special business case. Now we need to consider how we can support write and value transfer. Why this case is important? Because it's actually a showcase of the blockchain as a technology. And it is also a very common case. So we want to make sure that we will have interoperability here as well. And it is a very complex case, since write and value transfer can engage a lot of specific business logic and be a subject of regulation and compliance. To support value and transfer properly, we would definitely need a second level, an extension of the protocol that will introduce and implement more structure and logic that is required. This extension needs to be flexible enough to cover real-world scenarios and is a subject of additional research. So, to summarize, our assumption here, we don't need a traditional consensus in any version of the blockchain on a zero level. We also don't need a concept of a single chain. We also don't have to worry about protection of personal private keys too much. But we do need to protect chain integrity. We do need to accommodate complexity of the real world. And we do need to open source some key elements of our solution.
Andrew, thank you very much for providing great insights and what we would like to propose. So with this, I would like to present you a proposed blockchain interoperability architecture from our technical work group at SNIA, where we will build the blockchain layer with the storage, and then we'll have distributed ledger, blockchain services, smart nodes, authentications, and API. This is all still in the early stages, so stay tuned. And I would like to ask everyone in this audience to get involved. If you're part of SNIA member, please join our technical group. If you're not part of SNIA, please join us as a member of SNIA and join our technical group. You can contact us at membership@snia.org or Olga at my ActionSpot. And it will allow us to create a community where we will build an effective and viable solution for blockchain interoperability. Any questions? Thank you very much for attending today's sessions, and I'm looking forward to your feedback.